Hello and welcome to the video. This is an OpenTX quick tip. Well, quick-ish. This actually isn't one of mine. This is from a gentleman called Ulf, and apologies if I've just completely mispronounced your name, sir. This is one of those cool emails that I get occasionally from other people using OpenTX. If you haven't come across some of the OpenTX Mix School stuff, go and check up in the top left-hand corner here. Go and have a look at our videos. I start very simply to explain how OpenTX works. There's literally dozens of videos in there now, and they explain how OpenTX works and how to do some pretty complicated stuff. Now, Ulf got in touch and emailed me, and what he's talking about is he has a really cute little trick to help him launch things like wings, and that's to provide a little up elevator to help the wing get into the air. Now, that up elevator is immediately cancelled as soon as he starts to move the elevator or the aileron stick. Now, it's a really cute idea for helping wings get into the air, particularly if you're on your own and you're just lobbing them and you don't have a flight controller in it that will do some of the hard work for you. Now, when Ulf originally sent me his version, let me just show you it. This, I'm guessing, is kind of fresh off his radio. The way it works is that if you look in the inputs, it's pretty standard stuff. He's using a switch to switch between amounts of expo, and also for the ailerons part of the flying wing that this is part of, to switch between the travel as well. In the mixes, throttle's plugging into channel 1 of the receiver, channel 2 and channel 3 are the two control surfaces on the wing, but he's doing something a bit wacky here. This is the little bit both here and here that's adding that additional up tilt. So if I just simulate the radio to make sure everything's out of the way. The way it works is that at the moment, those are the default positions of the channel. It's 33 and 3. He momentarily flicks his little momentary switch on the radio, and that gives him the additional tilt that he needs. He increases the throttle, lobs it into the air, and then as soon as he moves the control away from the middle position, that additional elevator that's there to help the launch is taken off. That's a really, really cute trick, and when he explained it to me, I thought, well, that's got to be relatively straightforward. I love that idea. And then I tried to do it without looking at his mixes and got really confused, because the way that Ulf is doing this is actually really quite clever. He's using logical switches to detect the position of both the aileron and elevator, so when they move out of that middle position, and he's kind of combining them all together, so he has kind of one master switch that is L7 that's kind of detecting when the stick has moved out of position, and the fact that SH is involved in it means that it can be cancelled on and off. So let me show you in a slightly easier layout how he's done this, but I need to give massive shout out and props to him for figuring this out. This is some really quite cool stuff. It's a little bit complicated, so if this is the first OpenTX quick tip on the channel, go and have a look at the other videos. They'll probably start a little bit simpler. So here is kind of my version. So the way it works is there's nothing in flight modes. Flight modes is completely standard. There's inputs are exactly as you'd expect. I would probably add a little bit of exponential on here, just on the inputs, just to calm the control surfaces down if this was a real model. Then in the mixes, we have channel 1 and channel 3 are my two controls on the wing. So if I just simulate that, hopefully you can see here that channel 1 and channel 3 are both in their middle position until I hit that SH switch, and it gives me an extra little bit of elevator, and that's going to work fine until I fly around, and then when I let go, they snap back to their middle position, which is where they were before, until I hit SH again, and that gives me that's kind of my ready to launch button. So the way that is actually been done, let me go through this at a little bit of speed, but to explain it to you. You can see here that it's all been done with logical switches. So here's all the logical switches at the top, and what it's doing is logical switch 1 and 2 are detecting, you can see them turning on and off, when the aileron moves away from the middle position. Logical switches 3 and 4 are detecting when the elevator moves away from the middle position. So if we look at how the logical switches work, so we're saying logical switch 1, when the aileron is greater than -15, then turn on. And what it's doing is these first four switches here with A being greater than X, which aileron being greater than -15, what that's doing is means that the control in the middle position, quite cleverly, and this was the key, I think, to how smart this is when it's in the middle position, you can still fly around, do slight corrections, all the logical switches stay turned on until you push one of them out of position. And then when one of the logical switches go off, then what you have is this this kind of cool function. So what channels 5 and 6 are doing is they are kind of combining these two pieces together. So logical switch 5 is going to detect when the aileron has moved out of position. Logical switch 6 is going to detect when the elevator is out of position. So let me just show you that. So here's the aileron moving out of position. So individually logical switches 1 and 2 are moving. Hopefully you can see that. But every time we do that, it's logical switch 5 is turning on and off, because that is looking, logical switch 5 is looking at either logical switch 1 or 2 changing, which is good. Similarly, logical switch 6 is looking at logical switches 3 and 4. They're these two, which is looking at the position of the elevator. So if I move the elevator up and down, you'll see logical switch turn on and off. Now, what you need to do is, now we've got that kind of consolidated into two logical switches, we need to consolidate that one more time, so we've got one logical switch we can think about, and that is what logical switch 7 is doing. So it's bringing together 5 and 6, the previous two, so that you have one. So whenever I move the switch out of position in any direction, you'll see it's logical switch 7 that is changing state, irrespective of where I move the stick, whether it's left, right, up, down, whether it's the aileron or the elevator, logical switch 7 is changing. So now we can detect when the control has moved, and logical switch 7 is the one that we can do something with. Now we've kind of collated all those individual little tests, and it's slightly complicated, this, but there isn't an easy way to in OpenTX to say if a control has moved this far away from its default position in 2 axes. But what we do with logical switch 8, we sticky it for when logical switch 7 is turned on, i.e. when the control is moved out of position, and when SH, which is the momentary switch, has moved as well. And what that gives us is the desired result. So when we move everything around, you can see logical switch 7 is moving. Here we go, loads and loads and loads, but because there's no switch, it's not really affecting it until we flick that switch, and then 08 comes on, and that's what makes the difference. So now with these logical switches, we can detect the movement of the actual controls. Now we can actually do something in the mixes. So all we've done is added to each extra line. Source is max because it's not relative to any particular control, it's independent of that. We just want to add in a value of offset for the elevate. Could be anything. I think in Ulf's example it was 17. I've just put 15 here for a laugh. And we said when the switch is not, when switch L08, logical switch 08 is not on, then this is active. And that, those two pieces there and there, are the stuff that actually makes it work. So here we are, we're at the flying field, both the control surfaces are in their neutral position, we get ready to fly, we briefly pull the switch, and now we can see that we have that offset on the elevator. We apply the throttle, we throw it into the air, then we take our hands off the model, put it back and then start to fly the model, and that offset is immediately taken away. This has been a really interesting one for me. Occasionally I get these in and I think, oh, I wonder how he's done that. Let me see if I can figure it out before I look at their solution. And this was one that really flummoxed me. Some of the really smart ways that he's using the AND commands to collect all of the different testing of the logical switches is really, really smart. If you can think of a more simple way to do it, then please let me know. But hopefully this is interesting for those of you that like to launch planes and they could benefit from a little bit of extra elevator on that initial throw at the field. Thanks for watching the video and watching right to the very end. You can find me in all the usual places on social media, and if you like the video and like what I'm doing here, then hit the subscribe button and hit the bell notification icon too. If you really like what I'm doing, you can go the extra mile and become one of my Patreons for access to me directly for support, and also giveaways and regular updates too. If you're looking for particular content, then check out the playlist. I organise all of my videos into playlists, so if you're looking for a particular topic, you can find everything here. If it's called Introduction To, it's designed to start very simply and build on that simple introduction to teach you all about it. If it's called For Beginners, then that is really aimed at people who are brand new to that part of the hobby. You can also search on YouTube for anything that you're interested in using the search function at the top. So iNav Painless 360 will find all of my videos and even the playlist around iNav. So thanks again for watching and happy flying.